Hello students, you are welcome to Prepclass Tutors. With you is Mr. Chima, your Prepclass tutor on chemistry. So today we will be looking at WAEC past question papers on chemistry for the year 2020. Okay, so students, first and foremost, as we always say, try as much as possible to subscribe to our YouTube channel, like our videos, and do not forget to drop your views or any comments you have on your comment section box so that Prepclass will know how helpful our videos has been to you. Do not forget that there are also some students that have been looking for such an opportunity to learn one or two things that you have been enjoying from Prepclass Tutors by watching our video. So now this is why it is required that you should try as much as possible to share our videos so that it can reach as much students as possible. A friend of you can be needing this video, you may not know. I believe that some of you have friends outside your location. Yes, they might find this video very interesting. You don't know the problem that one or two students have. So by you sharing this video, it will reach much more students that have one or two challenges which they have been dreaming or aspiring towards solve. So quickly today we are going to be looking at questions number 46 to 50. So in a nutshell, we are going to be rounding off the past questions for 2020 by looking at questions number 46 to 50. 46 to 50 rather. 46 to 50. So quickly, let us start. Question number 46 says, which of the following processes is not exhibited by atoms in order to attain more stable electrons configuration? Which of the following processes is not exhibited by atoms in order to attain more stable electrons configuration? Now, remember that for atoms to attain a stable electronic configuration, they need to 1. Share electron. Are you following? 2. They need to lose electron if they are metals, and 3. They need to gain electrons. As long as that atom of that element does not belong to the stable or the ideal elements, you know that the elements they call the ideal or the noble gases, the noble or the rare gases, which are those that belong to group 8 or 0 of the periodic table, the noble gases. We have elements like krypton, xenon, neon, argon, and so on and so forth. Now, as long as such an element does not belong to this group, for it to attain a stable electronic configuration, it must do this either by gaining electrons if it's a non-metal, losing electrons if it's a metal, or sharing electrons. Do you understand? Okay, good. So you can see that for an element that attaining stable electronic configuration, hybridization is not one of them. Hybridization just tells us about shape of a molecule. Are you following? Shape of a molecule. So since they say the process that is not exhibited in order for an atom to attain stable electronic configuration, now the correct answer is what? Hybridization. Because it is not needed for an atom to attain a stable electronic configuration. We've listed the conditions which involve gaining electrons if it's a non-metal, losing electrons if it's a metal, or sharing electrons. Question number 47. Which of the following quantities is a molar quantity? Which of the following quantities is a molar quantity? Now, this question looks a bit kind of funny. If you see the option A, molarity and molar concentration is the same. I don't know if it's a typo or what. They gave you the same option in A and D, molarity. And number 2, they say which of the following quantity is a molar quantity. So molar concentration, molar quantity is supposed to be molarity or molar mass. Are you following? So molarity, molar mass are both the same thing. Molarity, molar mass, molar concentration, they are all mole quantities. Molarity, molar. But mass concentration is not a molar quantity. So I don't know if they mean which of the following is not a molar quantity. Maybe if they mean it's not a molar quantity, then your answer is what? Mass concentration. Because choosing this molar mass is a molar quantity. Now, molarity is molar concentration. Molarity is molar concentration, but molar mass is also they are both molar quantities. So the one that is not a molar quantity here is mass concentration. So that question is a kind of tricky or funny. Now, question number 48. Dilution factor is D. Dilution factor is D. They say A. Is it the amount of distilled water that is needed to concentrate a solution to dilute? Is it the amount of distilled water that is needed to concentrate a solution to become dilute? B. Is it the quantity of distilled water added to 1 dm cube of the concentrated solution to give the dilute solution? C. Is it the number of times the volume of the concentrated solution is diluted to give the dilute solution? And D. Is it act of diluting the concentrated solution to obtain the dilute solution? All these things look a bit, all these options look similar. So this question is a kind of very tricky one. It's a kind of very tricky one because they look somehow alike. But the first thing you need to do is to try to define dilution factor. Now, I said here that dilution factor is the ratio of a volume of a concentrated solution to that of the volume of the final dilute solution, or vice versa. So the ratio of the initial concentrated solution to that's the ratio of the volume of the initial concentrated solution to that of the volume of the final dilute solution. Or you can say the ratio of the volume of the final dilute solution to that of the what? Volume of the initial concentrated solution. That's dilution factor. Volume of concentrated to volume of final dilute solution, or vice versa. That's all. Volume of final dilute solution to volume of initial concentrated solution. Now, I say here that example, if the volume of the concentrated solution, maybe it might be sodium chloride or so, whatever. Now, if the volume of a concentrated solution is 20 centimeter cube, and the volume of the final dilute solution is 2000 centimeter cube, then what will be dilution factor? Remember that ratio means division. So you divide 2000 by 20. That's the ratio. The ratio is 2000 is to 20. Are you following? That means if you divide 2000 by 2, that will give you 100. So that means that the ratio will be 100 is to 1. 100 is to 1. So that tells us that the concentrated solution will be diluted 100 times. Now, for you to make a dilute solution of 2000 centimeter cube from a concentrated solution of 20 cm cube, if you divide 2000 by 20, you get 100. This means that the diluted solution will be to get the diluted solution, the concentrated solution will be diluted 100 times. Are you following? So because of that, your best choice is C. The number of times the volume of the concentrated solution is dilute to give the dilute solution. You can see that we got that from defining dilution factor, from the ratio of the final dilute solution to the initial. So telling you that is 100 times. So that's the number of times of the volume of the concentrated solution is diluted to give the dilute solution. The number of times the volume of the concentrated solution is diluted to give the dilute solution. So that C is your best answer. Question number 49. Calcium chloride is an ionic compound. Which of the following statements account for its ionic character? Which of the following statements accounts for its ionic character? Number 1. Is it that calcium has high ionization energy? Calcium has low ionization energy. Chlorine has high electron affinity. Chlorine has high ionization energy. Now, before you can answer, choose which one will work for an ionic compound like calcium chloride, you have to first of all explain what ionization energy and electron affinity is. Ionization energy is the energy required to remove an electron from an atom to form an ion with a net positive charge. The energy required to remove an electron from an atom to form an ion that is a positive charge is what? Ionization energy. So because of that, metals have lower ionization energy, because you can easily remove electron from metals. They can easily donate electron. The rate that is involved to remove an electron from metal is very small. So that means that metals will have a lower ionization energy because they can easily donate electrons. Non-metals have higher ionization energy because it's extremely difficult for them to lose or donate electrons. Non-metals like chlorine or oxygen do not donate electrons. So it's difficult for you to remove an electron from them. Are you following? So because of that, they will have a higher ionization energy. So metals have a lower ionization energy. Non-metals have a higher ionization energy. Electron affinity. Electron affinity is energy released when an atom gains an electron to form an ion with a net negative charge. So you can see that electron affinity is the opposite of ionization energy. The energy released when an atom accepts an electron to become a negative charge. Now, metals have lower affinity for electrons because metals do not accept electron, rather that they donate. So because of that, metals will have a lower electron affinity. Do you understand that now? Non-metals have a higher affinity because they have a higher tendency to attract electrons. So you can see here that metals have lower ionization energy, non-metals have higher ionization energy. Metals have lower electron affinity, non-metals have higher electron affinity. So for ionization energy, for both of them, ionization energy and electron affinity, for metals it is lower. Ionization energy and electron affinity for non-metals like chlorine, it is what? Higher. Are you following? So the first statement, calcium has a higher ionization energy. That is wrong. I will not go with number 1. Number 2, calcium has a low ionization energy. Of course, metals has a low ionization energy. I'll go with number 2. Chlorine has a high electron affinity. Yes, high tendency to attract electron. So 3 is correct. Chlorine has a high electron affinity. 4, chlorine has a high ionization energy. Yes, you cannot easily remove electrons from them, so the ionization energy is high. Remember I said that for both of them, chlorine or non-metal is high, metal is low. So calcium has a low ionization energy, correct. Chlorine has a high electron affinity, correct. Chlorine has a high ionization energy, correct. So 2, 3, 4 is the best choice. 2, 3, 4, and that is why we pick 2, 3, 4 here. That's why we pick 2, 3, 4 here. Question number 50 and the last. An example of a biodegradable pollutant is a plastic, B, sewage, C, carbon dioxide, D, carbon and hydrogen sulfide. You can see that all the substances listed here, sewage is an organic substance. Sewage is an organic substance because it's from our body. So since sewage is from a living entity, it is biodegradable. So without even looking at it, the answer is sewage. Why is it? Biodegradable or biodegradability or a biodegradable substance is one which can easily be broken down into simple harmless substances by the action of a microorganism. If somebody should drop sewage on a soil, what happens? You know, it will turn to manure. Cattle dung, poultry dung, even human dung turns to what? Manure. Why? It is sewage. What happens? Microorganisms like denitrifying bacteria and like Nitrosomonas and Nitrobacter can easily break down the protein, maybe the undigested protein in them, and yes, can easily break down the undigested, because sewage is an undigested food substance. So those microorganisms can easily break down the undigested protein in them towards simple substances like urea and ammonia. From there, they can break down that urea and that ammonia into nitrogen that can be easily absorbed by the soil. So that is why all these feces, urine or sewage can become what? Manure, can be converted to nitrogen by microorganisms. I will call that process biodegradable. So now you understand why sewage is the correct word answer. Alright students, we are going to stop there for today. Look at the link here. You will see a link to our WhatsApp group. Click the link and join us on our WhatsApp group. If you do so, you will always be having what information. You'll be carried along on any latest video that has been posted on our YouTube channel. You'll be carried on any latest video posted on our YouTube channel. That'll be very helpful for you, not only on chemistry but on every other subject that you would like to learn. So with that, we have completely finished or rounded off our past questions on WAEC from the year for the year 2020. We did questions 46 to 50. So maybe in our next video we'll be solving past questions on maybe biology or chemistry on any other year. So till then, I'll see you next time. I still remain Mr. Chima, your prep class tutor on chemistry. Bye and do stay safe.